Potential and kinetic energy test. Number 1, kinetic energy is A, stored energy, B, energy of motion, C, heat energy. Number 2, potential energy is A, stored energy, B, energy of motion, C, heat energy. Classify the following statements as either potential or kinetic energy. Use a P for potential and a K for kinetic. Number 3, a car driving at 60 miles per hour. Number 4, the wind blowing through the tree branches. Number 5, a runner at the starting line of a race. Number 6, a soccer ball being kicked. Number 7, a cat sleeping. Number 9, a ball at the top of a hill ready to roll down. Number 9, a swimmer doing the backstroke. Number 10, a bow with an arrow pulled back. Circle the answer choice that best completes the sentence. Number 11, one way that potential and kinetic energy are similar is that A, one is moving and the other is not. B, they are both involved in everyday life. C, they both store energy. Number 12, one way that potential energy is different than kinetic energy is A, potential energy is the energy of moving things and kinetic energy is not moving. B, potential is stored energy and kinetic is not stored. C, potential energy is slow and kinetic is fast. Next page. Use the picture below to answer questions 13 and 14. Number 13. At what point would the roller coaster have the most potential and the least kinetic energy? A, point W, B, point X, C, point Y. Number 14, at what point would the roller coaster have the most kinetic and the least potential energy? A, point X, B, point Y, or C, point Z. Use the diagram below to answer questions 15 and 16. Question number 15. At which point or points does the swing have the most potential and the least kinetic energy? A, points 1 and 2. B, points 2 and 3. C, points 1 and 4. Number 16. At which point or points does the swing have the most kinetic and the least potential energy? A, points 1 and 2. B, only 2. C, points 1 and 4. Number 17. Students conducted an experiment by stretching the same rubber band to various lengths, releasing it, and measuring how far it traveled. The length of the rubber band was stretched, 10 centimeters. Distance it traveled, 50 centimeters. The length the rubber band was stretched, 25 centimeters. Distance traveled, 80 centimeters. The length the rubber band was stretched, 50 centimeters. The distance traveled, 120 centimeters. Based on the chart, what conclusion can be drawn? A, the more mass that a rubber band has, the more difficult it is to move. B, the more potential energy put into a rubber band, the more kinetic energy released. C, the farther a rubber band travels, the less it can be stretched later. Extra credit. What is the name of the pneumonia-like virus that is sweeping across China?